A very good morning to everyone. First, I would like to welcome you all to the day 3 of National Level 1 week online workshop on research methodology and academic publications, with a special focus on use of scientific tools and software. I feel extremely privileged and honored to extend my warm welcome to our distinguished guest, Dr. Joydeep Baruah sir. Sir is a professor and director of Surya Bhuyan School of Social Sciences, Krishna Kanta Handik State Open University, Assam. A very warm welcome, sir. Before handing over to him, I would like to introduce him to our participants. Before joining the institute, Sir has worked as an associate professor in Omyo Kumar Das Institute of Social Change and Development, Guwahati. Sir has a keen interest in research areas including political economy of development and issues related to poverty and inequality. Sir has conducted and coordinated several large-scale survey-based studies for Government of Assam, Government of India, and other agencies. Joydeep sir was the principal coordinator and lead author of the Assam Human Development Report in 2014. Sir has also received a summer fellowship from the Oxford Poverty and Human Development Initiative, University of Oxford in 2015. Sir has made academic visits to a number of countries including Japan, Thailand, Greece, and USA, and has published in leading academic journals and currently serving as a member of the editorial advisory board of the of the Indian Journal of Human Development. Sir has been also one of the members of the committee constituted by the Government of Assam to restructure the state's economy in the aftermath of COVID-19 last year. And today we have him among us, and he will be delivering a speech on methods and techniques of data collection. With this, I would like to hand over the platform to you, sir.
Okay,
sir,
thank
please.
you very much. Can you hear me?
Yes, sir.
Okay, so thank you very much, and then good morning to everyone. So
Good morning, sir.
Today we will be having a session on the methods of data collection, and I'll be speaking basically not in too technical terms. It will be a general discussion because the time is very short, and also I guess the participants will be from different disciplines. So therefore, for some technical things may appear to be a little distant to them. So therefore, what I will try to do, I will concentrate basically on the common things which we follow, and then I will try to go into some detail on the survey method, which normally we apply in most of the cases for collecting data. And this is what is the plan. And let me now, share my screen first so that I can share the presentation as well as the whiteboard. So I guess you can see the presentation, right?
Yes, sir.
Yes.
Yes. So this is the topic that I am given, the methods of data collection. And as I have said, this will be a very general discussion because I will not be able to deal with everything that is there, which can be discussed within the framework of this class. But nonetheless, let's begin and then see how far we can go. Now, before I begin data collection methods, so let me briefly introduce the data and data types, because this data type also determine the methods that we apply to get the data. So therefore it is very important to recognize the differences between different types of data, and so that we can actually find most suitable methods of data collection. If we very briefly try to understand data, data is a plural form of the word datum. All right, datum is the singular form and data is the plural form of datum, and datum means the something which is given, something which is given. These are facts, and these are given facts, or these are taken for granted, that we do not question the the data as such, and whatever it is there, we take them as given, and these are the facts. And this is what we call data. So if we ask somebody that what is your age, and then he responds that, or he or she responds that he, her, or his age is 35 years, then we take that as it is, and we take that as fact, and then we call that this is the data. So data, if the basic idea of data is that which these are facts which are taken as it is, which are taken for granted, and which are taken as given. All right, so that's what we call data. Now the facts will come from observation. When we observe uh, the things around us, then we get all those data. And when we observe, observation means that you apply your five sensory perceptions, and then to get the data. And either you see, either you feel it, either you hear it, and then all the five sensory perceptions that we apply, and to get the data. This is called observation. And since we observe the facts, we take that as at the face value that is given, and we normally do not question the when we take that as data. And then since this is coming from observation, so it can take a number of forms. It can be numbers, text, images, sound. Image, for instance, suppose geography discipline use a lot of maps, and then also the satellite images, uh, aerial photography. So these are the sources of data. When we look, we take that as data. For geographers, that these are also data. The maps are data. The satellite images are data, and aerial photography, images are data. So they get all those things. And in some cases, we also take sound as data. So therefore, if we apply our sensory perceptions, so you can get different forms of data. It can be number, text, images, sound, and so on and so forth. So therefore, all these constitute data. All right. So, and accordingly, your methods will be different. And if you want to get, suppose, images, then the getting image is going to be a different method than asking questions to the households. All right. So therefore, because as I have said, that this is not going to be an exhaustive class as it is, because I cannot discuss much of the things, how to get the satellite images. That's a different topic, which is a very specialized topic, which is called Geographic Information System, GIS. So that's a different topic altogether. So I will not be able to go into that kind of specialized discussion. More or less, it will be a very general kind of discussion. So therefore, the most important point to understand is that these data can be taking, it can take different forms, because we apply our sensory perceptions, and accordingly we get different observations which constitute data, and these are taken as given. And since there are different forms of data, so there will be different methods of data collection also. Now,
Sir,
if we look at, yes.
Sir, please click on the hide tab so that we can see your full screen. This one, this Google meet.google.com in sharing your screen.
Yes.
In the side of the stop sharing, there is a one bottom hide.
Yes.
Yeah. Click on this.
Yeah.
Okay. Thank you, sir.
So now it's okay.
Yes, sir.
Okay. Now the idea is that when we take the data, if we talk about different data types, then we will have this. As I have said, that we have observations, and then we have different things coming up in form of observation. So when we try to get numbers, you have to understand the process. This is very important. Before we go into the method, you have to understand the process by which data are generated. If we want to get numbers, there are two processes which can generate number. Again, I will not be able to discuss too much on it. Just a reference. If you want to get numbers, how do you get numbers? There are only two processes which can generate numbers. One is the counting. If you count, numbers, how many, then you get numbers, or you have to measure it. All right. So if you want to measure, then it becomes number. So two processes can generate numbers. The counting is a one process, which is a very simple process, and the second process is actually the measurement. So there is a whole lot of theories of measurement and all these things, and based on that your methods are also going to be different. So this is, you have to keep in mind the underlying process by which the the numbers are generated. And when we have that number thing coming up, that means data are generated by these two processes, either counting or measurement, we call quantitative data. So you can define quantitative data in two ways, that anything which is coming as number is a quantitative data. So that's the normal definition. But for us, we define quantitative data that any data which is coming by two processes, either by counting or by measurement, we call quantitative data, which is actually the same thing, but it is slightly a detailed definition of quantitative data. That means quantitative data are numbers, and number can come through these two different processes. So anything which is coming by this process, that anything which we measure, we call quantitative data. All right. So that's the one idea of the data type, and largely we get this kind of data, we get numbers, and then we get quantitative data. But at the same time, there are a whole lot of other types of data. For instance, suppose text, images, sound, and all these things which are not readily as number, which are something else. And then all those things, anything which is beyond number is actually called qualitative data. But at the same time, there is a process by which we can convert the qualitative data into numbers as well by applying different methods of measurement. And for instance, suppose if you have, suppose forest coverage, you want to understand forest coverage, and then you take the satellite image, and you get image as which is not readily number, but those images can be processed through different mechanisms and methods, and those image can be generating different indices, which we call NDVI, for instance, the vegetation index. And looking at the vegetation index, we can actually categorize the areas under forest and all these things. So then it becomes number. So therefore, first of all, some data are readily number, immediately number, if it is coming from counts and measurement, and some data may not appear to be the numbers, but at the same time, if you go for some sort of measurements, then they will result in numbers. So then the qualitative data, which is non-number data, can be converted into the quantitative data also, and that we call quantification. The quantification is something which is not readily number, can be converted into number. So that's the idea of quantification. Then we call that this is quantified. These are expressed in terms of numbers. So largely, we get these two types of data, the quantitative and qualitative data, and part of qualitative data can be also quantified, and this is how this can be done. Now, so there is a process of quantification by which we can get this data. So this is one type, based on observation, based on the type of observation, we have two types of data. Now, it is important to understand, quantitative and qualitative data, that these observations can be generated from the same unit. If you look at the unit, the same unit can generate both the types of data. It is about the perspective, what you are looking for, the lens that you are trying to apply to see the things and observe. So that is there. And then there is a tendency that we try to put this vis-a-vis. That means that which one is better, kind of thing. But that's not the idea. The third point actually in the slide says that neither of them is in a conflict with each other, and then both attempt the same observation, and we can take together for understanding this data. Let me give you one example. Suppose if you look at the class, you go and then visit the class, and then you can apply different lenses. For instance, suppose if you apply a quantitative lens, then you will look for numbers. You will look for numbers, you will get numbers. Then how many students are there? How many are boys? How many are girls? What is the attendance? How many students are good in mathematics, English, and so on. So you are looking for something which is lens is actually how many. So you are counting, and then you get the number. So that is how you get it. The 672 students are there, this number of girls, this number of boys. So all the data are coming in terms of the numbers. So that's the lens, that you are taking, the quantitative lens. A qualitative lens will give you will not look for numbers. It will be looking for something other attributes. Suppose if for instance, suppose if you have a qualitative lens and looking at the observing a class, then you will look for something else, not the numbers, like the how what is the behavior of teacher, what is the behavior of student, how they react to teaching, what is the overall ambience and environment, what is the spirit of the teacher and student, what is the chemistry between them. So these are the things which are non-number attributes, so you are not getting the number. So therefore the same class, same set of people, same observer will get different types of data, quantitative and qualitative, based on the lens through which they are looking at the class. So therefore, same unit can generate both the types of data. That's that's the idea, or a qualitative and quantitative. All right. So now let me go to the second type of data, the primary and secondary. Primary and secondary data are something which are normally based on the both the types of data will be applicable. It is based on the use. That if you either if it is already pre-existing, it is already there, and you are just using it, and then or you can collect yourself. So that's the user collected data. So if we have that kind of a thing, then there are two ways of looking at the things. That first of all, it can be used for the first time, or it is already used and we are just quoting them. That is there. So if we look at this, that if you are collecting, and then obviously you are looking at the first time, but sometimes the pre-existing data are also used for the first time. This is it's a secondary data, but at the level of use, it is actually the first time use. And then pre-existing data already there, already used, and you are already used earlier, then you are actually taking that as the for your purpose. So therefore, based on the use, based on the observation, we have quantitative and qualitative, the lens that we apply, and based on the use, we have this primary and secondary data. If it is first time use, whether it is collected, user collected, or pre-existing, we call it primary data. And if it is already there and then we are just taking for the second, third time, then it is called the pre-existing data, then it is called secondary data. Now this difference of first time use and second time use is at some point of time may appear confusing, and that is why the history people actually take the archival records as the primary source, because it is already existing, pre-existing. But there are a lot of files are there, a lot of archival records are there, and that some of the files and some of the records are not used for the purpose that you are trying to use them. So it's a kind of a first time use for you, that you are looking these data, these existing records, existing archival records, and all these things for the first time for the kind of study that you are trying to do. So therefore, it is actually a primary data for you, because it is the first time use, even if it is pre-existing. So therefore, for history, the archival records and other such documents which are already pre-existing can also be considered as primary source or primary data. All right, this is about the use, whether it is first time use or the second time use. It's a very subjective kind of thing. Somebody can feel that okay, this is not primary, he will try as a secondary data. But in some disciplines, they can consider this as primary data as well. All right. Now, there is another division, that how you look at it. It gives you other kind of difference, that is called time series and cross section data. You can look at the data in a two different way. The first of all, if you have this thing that say this one will be kind of single point time point. That means today or 1 month. So time point is fixed. All right, the time point is fixed, and then you look at multiple units, multiple household, multiple kind of thing. So that is one way of looking at the thing. Or you can take one unit and you can observe over a period of time. For instance, suppose you look at a household over 30 years or 20 years. So household is fixed, single unit, and but you are looking at over a period of time. So that's another kind of thing which we, normally it is written, technically it is written as xi and xt. And if we look at the single time point in a particular period and a multiple unit, we call it cross section data. And then if we look at the single unit over a period of time, we call it time series data. And sometimes we have combined these two things together, that over a period of time, 20 years, 30 years, you are looking at a large number of units. So it constitutes a multiple units. So therefore, this will constitute a panel data. So accordingly, the analysis will be different. The methods of analyzing the cross-section data, methods of analyzing the time series data, method of analyzing the panel data are different. For instance, suppose those who will be knowing that there is a method called regression. So those regression for cross-section, regression for panel, and regression for time series will be different, because they will produce different kinds of problems, and those problems are to be handled before we go for any kind of estimation. So therefore, this is one way of the looking at the differences, the time series, cross section, and panel data. That how you look at the things. What is your time reference? Based on that, you get these kind of differences. All right, and we represent it by xit. That means I is also there, E is also there. So we are looking at the I's into units and also the T. So both are variable. So therefore, it is called the panel data. Now, last category of data type comes from the level of measurement. All right, you can measure, as I have said, the numbers can come from the measurement also, and then this are the 4 different types of data which is coming from different levels of measurement. Again, I will not be able to discuss too much on it. It will require again another class on this, that how do you do measurement, how these different types evolves, what are the problems. The first category is nominal or categorical data, that we do not have any measurement involved. So there is no measurement, only we have the categories. There is one, the idea which is called ordinal, second level, the ordinal measurement, that these are ordered data. We can say first, second, or we can rank them. We can say which one is greater, which one is less, which is called ordinal data. And then an interval data. Interval data, there's a fixed origin. There is a fixed origin. It just may not be 0, because origin normally when we start measuring, that you have to start from somewhere. If we start from 0, this becomes ratio. All right, but if for instance, suppose temperature is does not start from 0. If we have a 0-degree temperature, that does not mean that there is an absence of value. All right, 0 temperature is also a temperature. All right, so suppose 0 income does not have any income. So 0 has a meaning in ratio scale, that you do not have the value. But in interval scale, the 0 is not the origin. It will not start from 0, but it is starting from something else. For instance, suppose date is not having any, for instance, suppose if you look at the age, so your age will start from, say, date of birth. The date of birth is your origin, and then you start calculating. But date of birth is not your 0, but it is a starting point, origin, but it is not, the value is not 0. So therefore, all these data are called interval data. And then when the origin is actually 0, it starts from 0, it means that absence of value, then it becomes the ratio scale. So based on that measurement, we have 4 different types of data. So therefore, when we discuss data type, so you get quantitative, qualitative based on the lens that you use, based on the way you look at the things, gives you 3 types of data: cross section, time section, panel data. And based on the measurement level, you get the nominal, ordinal, interval, and ratio scale. And also you get the other types of data. I know this thing, the primary, secondary, user base. So these are the things that you need to understand: the quantitative, qualitative, primary, secondary, then time series, cross section, panel, and then these 4 types of data. All right, so these are different data types. Now, why this data type is important? This is important because of several things. That it depends on your data type, that how you going to analyze your data, how you are going to analyze your data, uh, how you are going to collect it, uh, what are the things that you will apply. All these things are actually based on the kind of data that you are trying to look at. All right, what you try to do, that comes from the data type, and then this data type will dictate your method of collection, your analysis, and all these things. All right, so therefore understanding your data, the kind of data that you look for, is extremely important before we go for method of data collection. So we have to decide that what kind of data that we are trying to use. So unless we have that, you cannot actually decide the methods of data collection. That if we say that, okay, I need numbers, then obviously you look for that what are the process, that either you have to count it, so kind of observation that will be there, what are the different methods of looking at the things, all those things will follow once we understand the data type, the kind of data that I'm looking for. So that's the primary thing, and that is why I put these things as a background, or at least as a beginning, kind of thing, before we go to the next part. All right, so that's the part 2. Part 1 is about the different kinds of data, because your part 2 actually is based on the part 1, that you have to decide the data type, and you have to decide the data kind of data that you are looking for, and accordingly you have to devise your methods of data collection. All right, so that's the framework that you have in mind. Now, as I have said, your methods of data collection, this is the topic. Your methods of data collection will be based on data type and also objective. That's what you want to do. That there will be study objectives. Objective means I'm not talking about the specific objectives of the study. General objectives. All right, general objectives. There are two, things which we look for the objectives. When we look at the objectives, and before we go into the methods of data collection and then the research methods and all these things, methodology and methods, all these things, we look at the two things in the objectives. One, what is the general purpose? General purpose are of two types. All right, general purpose are of two types. One, that either you simply want to understand or explore the thing, and this relates to your research design, that exploratory research, explanatory research and all those things. So general idea is that what is your idea, whether you are looking for simply understanding or exploring the thing, or you are looking for estimation. All right, so that's the first distinction that you have to make in the designing the objective. That what is the purpose? General purpose is whether to understand simply or to estimate the things. Estimate the things, and estimation is required. It is related to the kind of generalization will be attended. All right, extent of generalization. That if you do not want to generalize, all right, if you do not want to, go for any generalization. So, for instance, suppose for my research, I do not want to generalize for anything. I simply do not want to generalize. I just want to understand. Then you do not need estimation, and your entire data type, entire approach will be different. All right, but if you want to generalize based on your study, and then you have to go for estimation. All right, based on estimation, you will try to generalize. So therefore, there will be two broad approach of data collection. One, that where you will try to understand only, explore only, and you do not want to estimate, or you can try to estimate certain things and based on your study, and then when you have estimation, then you also try to generalize. So therefore, these are the two things, that what is the basic purpose, whether it is only about understanding and exploring and not about generalization, or it is also about, it is not only about understanding and exploring, but also about generalization, that then you will require estimation. So these are the two extremely important criteria for deciding the methods of data collection. All right, both the methods will have different kinds of things. The estimation, generalization will require a survey, all right, which I will come to in a later stage, and I will discuss more on this, some of the issues of survey. But but you can have survey without having any generalization, or without requiring to having any estimation. Simple survey, just to understand, just to explore. So that's a different kind of survey. So therefore, the idea of the methods of data collection actually predicated upon these two questions, that whether, what is the basic purpose, whether it is only to understand or to explore, or estimation, and if there is an estimation, what is the extent of generalization. All right, what is the extent of generalization that you want to attain. So that's the two things that we want to understand. Now, as I have said, that understanding and exploring, not really estimation or generalization. That's, if that is the kind of thing, then you can have the different methods of looking at the things. How do you understand? That you have to go see things, you have to observe and all those things. So therefore, basically, if you want to explore or if you want to understand, there are different ways by which you will look for evidences. You will look for evidences to support your understanding. All right. So why do you go to different places? Why do you go to different households? Why do you go to different persons? Because you look for evidences to support your understanding, that you want to say that this is the case. Then you, based on what you will be saying, you will be saying based on certain evidences, and these evidences can come only when you collect data. So this is the purpose of the data collection, the understanding and exploring the things. Here you can have a large number of the evidence. For instance, the one, the idea could be to look at the already existing thing, which we call secondary data analysis. All right. So this is one method of data collection. Data collection, what will you do? You will go for existing records, existing data, and then you go for the desk review of secondary sources, all such data, where it is available, and you try to collect that, you collate that, and then you try to see and analyze. So therefore, when there's a very primary level of the data collection, that is the a very simple level of data collection can be looking at all the sources of secondary data, and then try to collect and then try to collate them for understanding. So that this is one method which we call archival record or desk review of secondary sources. Now this can be this is also a very extensive work, that locating sources, looking at the data that you are looking for, obtaining that, collecting that, collating that, analyzing that, making sense of it. So all these are involved here as a process. So therefore, and you can have different sources of data, secondary sources. First of all, you have to understand the sources. Now, two things are very important here. One is that when you try to apply the secondary sources for your study, then you need to take care of certain issues. One issue is that you need to understand the context of the study by which these data are already generated. How process, the underlying process, that what was the process of generating those data. For instance, suppose if you look at some data like the recently the family health survey, for instance, suppose the national family health survey data. National family health survey data are in the news because it is saying that all sorts of things regarding the level of healthcare, level of malnutrition, level of the fertility rates of different communities. So these are already there. So if you are taking those data for your research, then you have to understand the process by which those data are generated, and process by which those data are collected, what was the time, and all those things. Second idea, the second issue is that these data will be coming from different methods. These data will be coming from different time points, the reference points. So when we combine those data, then you have to be very careful about those, compatibility of those methods applied to generate the data, and also the time period applied to collect the data. So therefore, these are the things that you should keep in mind. Again, the use of secondary data itself requires a discussion, separate discussion, but nonetheless, this is one of the methods that we can apply. All right. Now, second, the method is what we call observation method. All right. Now, observation can be of two types. One is the direct observation, and then other one is the participant observation. All right. What is the direct observation? That you go and then see and then observe and then get the evidence, get the data. All right. So that is there. This is one type of, the observation. Normally, what has happened, that suppose you visit a place, you go to the things, and then you see things for yourself, you talk to people and all those things, and then this is the direct observation. You go as an outsider and then observe from outside, and then you get the things done. I mean, get your data. But there are, again, we have different issues. We have a problem of subjectivity. There's always a question of objective observation and subjective observation, that your own kind of value judgment should not influence the finding. So that's there. So how do you balance it, and all those things are very important issue. But at the same time, the method is that you go and observe from outside. There is another type of observation which is called participant observation, that you become one of them. You become one of them, and then by doing that, you become a part of the group, and then you observe as a participant, and then you try to live through the experience, and then feel it for yourself, and then this is how you get the data. All right. So there are two ways of looking at the things. One is the direct observation method, and then where you look from outside, and then there is a participant observation method, by which you become a part of the group or part of the entity, and then you live through the experiences, and from that you understand, explore the thing, that what is actually the case. All right. Now, when you have the direct observation method, you can actually, this is another way of looking at the things, that you can actually look at the things for yourself from outside, or you can talk to people. Now, when you talk to people, we call it the interview method. Interviews, in-depth interviews. All right. You talk to people in detail for a longer period, and this interview can be a slightly one variant. That is it's a simple variant of in-depth interviews called key interviews, key informant interviews. Key informant interview is what? That you look at the person who is a key information, who can provide key information, and then you talk to them in detail. So either you talk to the people in detail in general, or suppose you go to a village and then you want to understand the health scenario. All right. And then you pick up 5-6 people to talk about the general health condition in the village. What are the diseases, what are the things, and what are the facilities. So you discussed all those things. So that's an in-depth interview in the village. But if you look for someone who can provide your key information, then you can identify those people. For instance, suppose if there is a health center, and then you go to the health center, and any health worker you talk to, then he becomes a key informant, because he is a specialized entity giving all those information. Or you can talk to, say, suppose Anganwadi worker, or you can talk to, say, ASA worker. So these are looking at the health at a grassroots level, and therefore they become key informant about all those things. So therefore this interview can be general, or this interview can be key informant interview, that you can go for somebody who can give you some more information. So therefore we are, from observation, direct observation, looking for yourself, you have gone one step ahead, understanding the things, to talking to the people. Either it is general, or you know it is a key informant interview. So it will based on your kind of data that you are looking for, and also the objective of the study. So that is the thing. Now, the one, again, one type of is that, instead of talking to them individually, if you collect them in a group of 5, 6, 10, it is called focus group discussion. All right, so group talking. Now, group discussion, but it is focused FGDs. What we call FGDs, that focus means that you have issues in mind. This is the focus discussion on certain key issues, and you have a small group, uh, and then you talk all those issues to the group. So this is a focused group discussion. It is focused on certain issues, and it is a small group. So instead of talking to individual, so you are taking them together, and then it is a focus group discussion. Ideally, in focus group discussion, and this is again is a method by we can discuss at length that how to do focus group discussion, what are the different methods, how do we analyze the focus group discussion data. All those things are there, but this is not about that. It is just to highlight that this is one method of data collection, that you go and then you constitute a focus group for your kind of study. And constituting focus group will require certain activities. Just like that, you cannot collect people and start talking. So it needs a background work. You need to sensitize that what are the things that you are looking for, and then you fix the meeting, and then you will need support of 2, 3 more people. It should be recorded by someone. Somebody should be taking notes, and then you lead the discussion with your issues. And then if you see that somebody is dominating all the time, one person is talking, then somebody has to take initiative to get other people to talk. So therefore, all those mechanisms are there. That running a focus group is extremely tricky, because you get 1 or 2 persons voice rather than a group voice. So it has to come as a group voice. So there are ways of doing it. So all those things are there. But the point is that instead of, the idea is to have a kind of understanding, kind of data, kind of insights from a group rather than individual. All right. So because when we talk in group, then it is also cross verified. So somebody is saying something, then somebody will correct, no, that's not true, it is actually this. Then through negotiation, you will come to a truer picture than individual talking. Get my point? So therefore, in some cases, the focus group discussion can be extremely useful in getting data. So therefore, the desk review, the observation, direct participant, in-depth interview, talking to people individually, key informant, and then focus group discussion, all those things are there. Another way of getting data in some of the cases, and in most of the cases, is called ethnography. Now, ethnography is one variant of participant observation, that you become you go and then you stay with them. So you become a participant in the sitting, in the observation. But the basic idea of ethnography is that you try to get data, or you try to understand the things, explore the things in that particular cultural and social settings. Get my point? So you try to understand, try to make sense of the setting that you have, socio-cultural setting, and then you try to locate your understanding within that setting. So that's the ethnography. So you, as a method, it is actually a type of participant observation. You become a part of the village, you become part of the household, but you stay with them for a longer period of time, and then you become used to them. And it is important to stay longer period, because you have to you have to get absorbed in that cultural setting to realize the kind of thing that is happening. So therefore, that is called ethnography. So this ethnography is one way of getting the data if you want to understand or explore. All right. So that's the ethnography. And then you have another method of doing it. This is called case study method. Now, in the case study, what you do actually, that you have to identify cases. Now, a case study, for doing case study, there are different, again, we can have a session on case study, then how to select cases, what will qualify case. Somebody has to qualify as a case, then why do you select someone as a case? That it has to qualify as a case. So either if you are looking for, suppose, success, then all those success cases will be studied. If you want to understand why a program fails, then failure will be the cases. So you have to identify the cases based on the failure. So therefore, first of all, you have to select the case, you have to qualify as a case, and then you study. And when you do a case study, that you understand why it fails or why it succeeds, why that particular case, how it actually operates, and through that you try to understand that what happens and what goes wrong and what goes right. You try to explore, and this is also a method of data collection. So therefore, this is one way of, another way of looking at the things, that this is how we go for the case study method. And also we have got the oral history. All right, the oral history, and you have you talk to them, old people, about their past and all those things, to understand the present and relate past and present. So that is how the oral history is done. So therefore, the point is that this comes from the first earlier slide, that it depends on the kind of data and kind of objective that you have in mind. The objective, as I have said, either you have to understand and explore. So if you have this, all those understanding and exploring, it is not about generalization. You do not want to generalize based on what you think. It is about that this is the understanding. This study is about understanding the thing. So therefore, that understanding the phenomena, understanding the what is happening. So this is how it is actually presented, without having to bother much about estimation and for generalization. So this, if you are more inclined towards understanding and exploring, then obviously you will have this kind of methods for data collection. Data will be coming from your objective and data types, and you decide that what are the things that can be done. So you can look for secondary data, you can look for observation, you go and observe the things, you become a participant, and then try to realize. You talk to people in depth interview, you talk to key informant interview. Instead of talking to individual, you become you make a group, so it becomes a focus group discussion. Or you can stay for a longer period of time, a part of the cultural setting. You try to be normalized in the cultural and social setting, and try to see for yourself the meaning of the things within that setting. So it becomes the ethnography. You look for certain cases, and then you study the cases in detail, so it becomes a case study. Or you can talk to people about their past to understand the present, so that becomes oral history. So understanding and exploring will require, you can apply any one or combination of these things. It's not that only one method is suitable. If you combine some observation, some in-depth interview, some key informant interview, some focus group discussion, and one or two case studies, so it makes a combination of all these methods, and finally you present that this is what is my understanding, this is what I have got in my research. So that's the first part, if you are not bothered much about your estimation thing or generalization thing. All right, so that's the first part of the thing. Now, if you want to generalize, so this is a more of a different kind of idea, that if you want to estimate and then you want to generalize, it is called few to all. That's a different kind of way of looking at the things. It is not only about understanding and exploring, but it is about generalization. So you need to estimate. The idea is that will require sample survey. All right, the sample survey will give you simple understanding. At the same time, it will also allow estimation and generalization. All right, so what is the estimation and generalization? We estimate the sample information. So what we have, we try to estimate. If we collect, suppose 100 data, and we try to estimate 100 data, all right, this we try to estimate sample information. So this is called the statistic. We estimate the statistic. All right, the sample information, sample characteristics, it is called statistic, not statistics. It is called statistic. And then you try to based on what you get for the sample, 100, 200, 300 sample, then you try to generalize for the population. That based on this result, I will try to generalize. All right, I will try to generalize that unknown. This is called parameter. Parameter is for the population. So based on what we try to do, we calculate the statistic and then try to estimate the parameter. All right. So it's not the true value of the parameter. It is the estimated value of the parameter based on your sample information. So that is the process of generalization. That from your sample, we actually say that if it is true for this sample, then this should be the case in the population. So that's a generalization. All right. Based on your result, you actually try to estimate the population parameter. So that is what is called the sample survey. Now, ideally, if you do not want to get into those kind of estimation and generalization, you need not have a sample. You can have a sample for only for understanding or exploring the things that as a method. But idea of sample survey basically not only having an understanding but also an estimation and generalization. So then only sample makes more sense. So therefore, I distinguish broadly in two types of methods. One is the simple understanding method where we get all those methods, the desk review, the observation, participant direct, in-depth interview, FGDs, ethnography, case study, oral history, all those methods I have in mind. But if you want to have the other set of objectives along with understanding and exploring, that you want to actually predict the population thing based on the certain things your study, then you actually tend attempting at generalization, and then you will need to have a sample survey which is to be designed very scientifically, because it is the based on the sample result you are trying to make certain claim about the population. So that is to be understood. So that is the sample survey thing, and I will give some time in this discussion that how we do it and what are the issues and what are the things that we should be looking for. All right. And when we try to do sample survey, all right, then we have two issues, and then I will discuss something on this, that what should be the right sample size, that how many units should be taken to properly estimate the population, that what should be my right sample size, whether 200 is good enough, whether 300 is good enough, whether 400 is good enough. How do you decide? All right, how do you decide about that? And how do you make your sample representative? Once you decided, okay, I need to have 200, then how do you select those 200 units so that that becomes representative of the population? So therefore, one is the sample size question, and the second one is actually sample selection question. So how do you select those units once you decide the size? So these are the two fundamental issues in sample theory, and this is called theory of sampling. Theory of sampling is all about making a right choice regarding the size and making a right choice regarding the method of selection once the size is determined. So these are the two fundamental issues which we can discuss more on this. Now, issue number one, all right, determination of sample size. How do you decide about the sample size? Now, as I have said, that the sample theory is basically about the generalization. So you have to make a statistical generalization, that you have based on your finding, you have to say that, okay, I have got this, but in the population, this must be the case. All right, based on this finding, I predict, I estimate that this is going to be happening in the population. So that's what we call statistical generalization. Get my point? So that is what is the idea. Now, the ideally, we have a common tendency of generalization, right? Ideally, we have a common tendency of generalization. All the time, people tend to generalize. Based on your experience, you try to generalize. For instance, suppose, let's say a classic example. Suppose two persons are sitting in a room and we have not seen them. And if we come to know, one information is provided to you, that if we come to know that one height of one person is actually 5.11 and the other one is 5.2, then what would be the safe case about their sexes? Now, which one is male and which one is female? All right, that you have not seen them. They are sitting in some room, and the only information that you get is that one person height is 5.11 and other person is 5.2. So you want to guess about their sexes. All right, which one is male and which one is female? So what will be the case? What will be the common case? The common case will be that okay, the 5.11 and 5.2. So 5.11 is taller, so this person should be male, and 5.2 can be actually female. So this is coming from your generalization that male are taller than the female, and you apply that logic, and then you based on that you try to generalize. You generalize idea is applied, and then you say that okay, the 5.11 is actually male and 5.2 is actually female. Now it need not necessarily be true. My point, it need not necessarily be true that 5.11 can be actually a female and 5.2 can be male also. So therefore when you go and then see that, you find that okay, this is not the true, and then there is a deviation from it, the true value, and that is what we call error. All right, that is what we call error, that we predicted something in the population and then population is something different. So there is a deviation from original value in the prediction value, so that will constitute error. Now statistical inference or generalization tries to, first of all, it acknowledges this error, that since it is based on very few information, and based on that we try to generalize, that there is a possibility of error. So we acknowledge this error, that there is a possibility of error, and which we call sampling error. All right, which we call sampling error, since we are we are basing our finding based on very few information. So therefore there is always a possibility of error, sampling error, and we try to reduce the sampling error, we try to play around it, and this is what is all about the sample size estimation theory. So first of all, you acknowledge that since you are trying to estimate the population based on very few, so there will be a difference, and there will be an error which we call sampling error, and we acknowledge it, and we say that we have to reduce the possibility of that sampling error. So minimum, how we can get better estimation, we can get better estimation by reducing the sample error. So we try to play around it. All right, now how do we do it? In the generalization theory, when we try to generalize based on your sample result, and based on your sample result you try to generalize for the population, we do not mean same, but we mean similar. All right, what is the difference between the same and similar? Same and similar means that if we get sample value as 20 and then we try to generalize it for population, we will not say that population value is exactly going to be 20 like the sample, but it is going to be somewhere near 20. All right, it is something going to be similar to 20, it will be close to 20. All right, so you accommodate a possibility of error. So you are not saying that it is exactly going to be 20. If it is 20, then error is 0. There is no error. Whatever is the sample value is the true value in the population, so there is no error. But you don't know. So since you don't know, so therefore we are not going to say that the sample value is exactly the population value. Population value is exactly the sample value. So therefore statistic and parameter are same. We are not saying that. We are saying that since I have got 20, so I expect that in population the value is something going to be like 20. It will be around 20. It will be similar to 20. It's not same as 20, but it is going to be similar to 20. When we say that similar to 20, so we actually accommodate that there is a possibility of error, and we accommodate it. All right, we accommodate it, and that is what we call the game of error, and we play it, and then we get the sample size theory. So first of all, how do you accommodate it? First of all, let us consider height of a person that 5.8 feet, and we have that. This means that there is a population, and then we take only one person's height, and we have got it 5.8. So therefore, based on that result, you get to generalize that what should be the population height. So it's possible, but point is that if very small information, based on small information you can generalize, the point is that there will be huge error. There will be huge error. So you are not very sure that too many possibilities will be there, so there will be large error. So therefore it is very clear that if you have a very smaller information, then error will be very large. So there, and then if you collect more information rather than one, and some more information coming, then it will eliminate, all right, it will eliminate some of the possibilities, and error becomes lesser and lesser. So therefore this whole idea that the relation between error and observation unit will give you the relation that sample size and error are inversely related. That means that more you have the units, the error is going to be less. This is the first relation. All right, this is the first relation, and based on that we get the first the equation that we have, that sample size and the error are inversely related. The more you have units, the error is going to be less. So this is what we have. Now one idea is to understand that when we say error, that what error we are talking about. All right, when we say error, what error we are talking about. Suppose, let us have one example. Suppose you have 100 units and you have decided to have a size, sample of 25. Now clearly this same size sample, you can have multiple samples. For instance, suppose if you have 100 units in the population and you want to have a sample of 25, then 4 different samples are possible, each of size 25, that you can have 4 different samples, and all these 4 different samples will be giving you 4 different values. All right, these are all different values. All right, so therefore the idea is that when you have a sample, ideally anything that you want to estimate will be having a sample distribution. That means this will be distributed across different samples. All right, so when you have that sample distribution, we have an idea of standard error. That means that if you have this idea that you can get this sample will give you the result 1, sample 2 will give you result 2, sample 3 will be giving you result 3, sample 4 will be giving result 4, and ideally these are going to be different. Now when these are going to be different, if you try to get the standard deviation of these results, then we call the standard error. All right, how different they are. All right, now this standard error idea is extremely crucial in sampling size determination. All right, what is the sampling size determination? That when you are safe if there is no difference. You are safe if there is no difference. That means standard error is equal to 0. Get my point? That there is no difference, so there is no error, so the standard error is going to be 0. That means whenever you take any sample, the results are going to be your result only. All right, so that means you are perfectly safe in generalization that this is going to be exactly the population thing, and if it is, then there is no difference, and that is why we say that there is no standard error. Standard error means the difference. All right, so and if you have a huge standard error, then you have a very different problem in generalization, because if you say something, then other sample will be giving different results, so your results are not going to be exactly the same result that is there in the population. So therefore there is a problem, and then we have the relation. What is the relation? The relation is that this is the idea that safest guess will be when the standard, all the sample will are same, all samples are same, and then accordingly the sample results are same, so therefore the standard error is equal to 0. So ideally the safest guess will be when the sampling standard error is equal to 0. Now since it is not going to be 0, so it is going to be good if we have the minimum standard error. So since it is not going to be 0, all right, so therefore we will be looking for minimum standard error. The more closer to 0 is good. And when it is going to be high, it is going to be high in the case of, so look at this diagram. So suppose these units are different, these units are different, these units are different, these units are different. So then your standard deviation of these things are different, the variability is very high, then you are going to have a separate standard error. So your standard error is going to be very high when you have sample variability very high. All right, if your samples are different, your sampling distributions are going to be different, and standard error are also different. So you have two relations. One is that standard error is actually related to the size, the number of units, inversely related. The more you have the units, then less you have the number, I mean the error. And variability, the sample variability and standard error are directly proportional. So these are the two relations which are used to determine the idea. So we write it like this, that standard error, if we combine these two equations, it will be like standard error is equal to the variability divided by size. So this is the definition of, when we combine these two relations, it will become this relation. So sample size inversely related, it is below, and variability, it is above. So therefore this is there, and then we use this. This is the crux of the sample size theory, and based on that we calculate the sample size. I do not want to actually discuss much on the calculation part. It is there in the slide. I think that this will be sufficient, and then I'll just keep some of the things, and then I will come to here. Now, as I have said, that when I have the standard error, then when I have standard error, then we will use this standard error to predict. As I have said that we are not going to be same, we are similar. Then we will try to have an idea called plus minus standard error, and this is your neighborhood, and that we call confidence interval, and based on that we try to generalize. So I'll just use a whiteboard here, just to give you some sense of it. Let me clear a Jamboard. All right. What I mean by this, let me explain. All right. So basically, what I'm trying to see is that if you, as I have said, suppose if you have a if you have some result, if you have say some result like I already said that suppose your sample result is 20. All right. So if you have 20 and this is your sample, all right, and then you want to estimate your population, this is the population, all right, then we will not say that this is exactly is going to be 20, but it is something near 20. All right, something like 20. All right, you have to construct a boundary. So if we can construct a boundary like it is 18 to say suppose 22. So we are saying that it is not exactly 20, but it is something like 20, and we expect that population is going to be something like 18 to 22. So that means we are saying simply that it is actually not 20 but plus minus 20 plus minus 2. So 20 minus 2 is 18 and 20 plus 2 is 22. So therefore the idea is that when we try to estimate, all right, when we try to estimate based on sample result, we are not saying that it is going to be same, but we are trying to construct a neighborhood, an interval in which we expect that population figure based on this thing, and that is how it is called. That is not same, but it is similar. So therefore we need to construct a plus minus something. All right, if you have 20, then you need to have plus minus something to construct this boundary, that where we can expect the population thing. This is the generalization. So this standard error will give you the idea of that thing, that this is, that if you have anything 20 plus minus standard error, and this is what is the nearness boundary. Now the ideally, this is the utility of standard error. Now ideally, if you try to see that thing, then you get what will happen. Suppose if you have a standard error more, as I have said, that this is your 20. What we have 20 plus minus standard error. All right, 20 plus minus standard error, and your standard error is very high. All right, standard error is very high. All right, so your standard error, this is greater, very high. Then what will have, suppose 20 plus minus say 10, so it will give a boundary of 10 to 30. All right, so you have a larger boundary now, around 20. So you have larger boundary, that means you are not very sure. So your error is very large, so you are not very sure. So you want to be safe so that you can accommodate all those results. So you are constructing a larger boundary, that the standard error is very high. Now if your standard error is very less, suppose it is 2, so you will have a relatively smaller boundary, because you are more sure about your results. So you will say that, okay, this is actually 18 to 22. So therefore the boundary that you construct will show your confidence, level of confidence. A higher boundary, confidence interval. The higher boundary, your confidence interval is greater. So your, means that you are not very sure. But if you are very sure, your boundary will be small, and that is how it is called, your confidence is very high. So this is what is the definition of this slide, and this is what I want to state. The first point, that if you have standard deviation, standard error, and then you will have this boundary, this plus minus boundary we call confidence interval. All right, that larger is the interval, less is the confidence, as I have already explained, that this is what is the idea, and that is how it is done. And then level of confidence is something, the confidence interval is the interval, this interval. All right, this is the interval, and this is called confidence interval. But level of confidence is that if you repeat the exercise, as I have said, that there can be large number of samples, not only my sample is there, but other samples can be also there, that if we do that repeatedly, then how many times the results are going to be within that interval is called level of confidence. If we say that, okay, level of confidence is 90%, that means if you repeat 100 sample, that results, the 90 cases result will be like my result. So that is the level of confidence. So this is the idea of confidence interval and level of confidence, and this will give you a kind of sense that how the thing is determined. All right, how the sample size is determined. So this will give you the, I'll skip this formula and all these things. All right, I will skip this formula and all these things. It's not required. All right, so we will use that thing to get the result. I will show you something on this, and then I will come back to design effect and the response rate and adjusted response rate. So I'll just come little later, and let me now show you how this is done. So if you, how do you use this idea? Say suppose if we use any sample size software, suppose let me use Rasoft. All right, then it will ask you certain things, that what is the margin of error, that means what is the error that you are thinking about, plus minus thing, that so your results will be interpreted in terms of that. Get my point? So your results will be interpreted in terms of that. So I take this 5, so I am taking that plus minus 5. So whatever result I will get, I will take it a first plus minus 5. So 5% means the 0.5, 0.05. So that's the result. And then confidence level 95%. That means if we repeat it, repeat it 100 times, how many times I expect this result, the high precision, that is 95%. Then population size something, and then what is the distribution. So you get, you fill up these things and total number, and this is the by default 50% is the by default number. So therefore anything that you have, it will be calculating your sample result. The 377 is your sample that is required to interpret the results at the 5% margin of error and the 95% level of confidence. So therefore this result, when we try to write it in a case, then we will have like, that anything, that if we have 377 units of sample, then what we can do, that anything coming from this sample will be saying that if we get 20, then your plus minus is going to be 0.05, because we have estimated this sample size for this error. So we want to have a boundary of this kind. All right. Now, if you want to go for more error, suppose more error means suppose 10%. So I want to have the 10%. So it is greater. Then obviously your units will be less, because less unit will be associated with the higher, error. So if we look at it, so make it 10%. You look at it 10%. So it becomes 96. That means now you do not need the 377. You do not need 377 because you have accommodated too many things. You have increased your confidence level, confidence interval, and that is why your drastically reduced to 96. So you can do a survey of 96, but your results will be interpreted not as a 20 plus minus 0.5, but your results will be interpreted as 20 plus minus 0.1. So this is what is going to be the result. So this is the result. So you are accommodating more. So therefore you can play around with your error and decide your sample size using the formula. All right, this formula works with those fundamental relations. So therefore this is what is the idea. Even if you reduce the level of confidence, suppose 5%, and you make it suppose 90, then also slightly reduce. Instead of 377, your sample result will be, how many units are required? 267. So you can play around with this error and confidence and get your sample size determined, and then you will write the sample size that okay, this sample size is good enough for this level of prediction. All right, this level of prediction, that means we will have a margin of error this percent and confidence level this percent. So this is the sample size thing that we have to calculate, and this is how this is how we do. Now the point is that this is all these things are required only when you have the estimation thing as your thing. That most important thing is that you are looking for estimation and generalization. Then only all those things are required. Otherwise, it's not required. You can go for simple sample size and then do a survey, but these things are extremely important for estimation purposes. All right, if you are looking for estimation and then generalization, then only these things are required. So what is the procedure of sample size estimation? That various sample size formula are available, and it always comes from the original relation that I have already explained, that inverse relation between sample size and the the error, standard error, and the variability of sample and standard error direct proportional. So you will get all those things. All those formula you have to supply some of the things, and you have to give the the probability, which I have already given 50%. Then which is the maximum sample size it calculates, the expected margin of error, and expected level of confidence. If you know that, if you supply these things to your formula, the sample size will be calculated. All right, so that's the issue number one. So what was the idea? Let me recapitulate before I go to the last part of the presentation. That what was the idea? That we, your method of data collection is based on the data type and objective. Now, objective are of two types: either you simple understanding or exploring, and then you have a lot of methods, including survey. But if you want to have not only understanding and exploration, but an estimation and generalization, then you have to go for a sample survey. Now, in that sample survey, the two questions are very important. One is the what should be the right size. So that size can be calculated by the different formula, but you need to understand what goes into the formula, and that is why I decided to discuss some of the points. I have not touched upon all the points because it's not a specialized class. We have people from all disciplines, just to give you a sense that what goes into the thing. And that sample size formula comes with the idea that there is going to be an error, and then the kind of error that we are trying to accommodate. If you are trying to going for very precise, then you have to have a large sample. But if you do not get money, you do not have time, then you can go for a very small size. In that case, only thing that will happen is that your confidence interval will be too large, and you will be having a large number of errors. So you have to take a call in between, that how to make a sample which is reasonably good with error and which can be used for prediction. That's what was the discussion till now. Now let me go to the second issue of selection of the sample. This part I am not going to discuss in too technical terms. I just introduce some of the things, and then I will end, and then I will take some questions. Now, when we try to select, the first thing is done already, that we need to select 377 units. We need to select 267 units. We need to select 96 units. So we know the number, how many units we get to select. Now the question is that how do you select those 300, 296 units as a representatives of the population? All right, the first case is the representation. Now this representation comes from the randomness. It is believed that your choice has to be very fair if it is to be representative. If it is biased, then your choice is not good. All right, we do not go for biased choices. We go for always the unbiased choices. So that's the idea of randomness. If you allow randomness to operate, then we have the unbiased, the kind of selection, and that is what is the idea. Now the randomness means that you have the equal probability of a sample getting selected. So that's one. Second idea is the proportionality, and these are the two ideas that I will use, and then I will discuss different selection methods. Now sometimes the proportionality is important. For instance, suppose so if you have a class of say 100 people, and you get 60 boys and 40 girls, and then you want to make a choice of 10, and then you do a pure random sample, it might all happen that all the 10 selected the students can be boys, or all students can be girls, because it is pure random. All right, so in that case you will not get boys in one sample or girls in other sample. If you think that is okay, then it is okay. But if you think that you want to study the difference between boys and girls, that means the categories are systematic relation. There is a relation, systematic relation among the categories. You want to see the differences of performance between boys and girls, because you believe that being boy or being girl has something to do with your performance. Then you need to have both the units. So then the same proportion has to be captured. That if you have 60-40 in the class, then your sample of 10 should also have at least 6 boys and 4 girls, so that proportion is represented in the sample. So therefore, in the representation, two things are extremely important. One is called the randomness, that is the allowing probability to play rather than bias of selection, and second one is the proportionality. Now combining these two, we will have these different methods of the sample selection. They call the simple random sampling, stratified sampling, systematic sampling, cluster sampling, multi-stage sampling, and mixed sampling. All right. Now, simple random sampling is it's as it is said that it is simple. That means that you have a population and you allow units to have the same probability of getting selected. So it's a simple random sampling. Now, stratified sampling is you have to divide into strata based on some attribute, and then you ensure that all the categories, all the attributes are getting represented in the sample. So that's called stratified sample. Now, systematic sampling is all about having the random sampling in the first, and then systematic sampling means it repeatedly you have the same number of units getting selected. So that's called systematic sampling. That means that suppose if you have 100 units and you want to have say 10 units and you want to go for systematic sampling, then what you do, you have to select any one of the units from the first 1 to 10 at random, and then every 10th unit will be selected as the subsequent units till you get the total number. I will explain that a little bit later on. Cluster sampling is called the area based sampling. All right. So if you have say the villages, then you divide the village into two clusters, and then three or more clusters based on area, and you then select it. Now there is a difference between stratified sampling and cluster sampling. In the stratified sampling, the within group are homogeneous. That means if you have boys and girls, if you have ST, ST, OBC, so you can have those data, and within data these are homogeneous. But in cluster, we try to do it in a way which are heterogeneous. All right. So, and then multi-stage and mixed sampling. So here we combine different stages and we combine different methods. Now let me just give you some idea regarding these two. First of all, let me give you a sense of systematic sampling or stratified. Now, stratified sampling, all right, when to do stratification? It is always based on attribute, first of all. All right, any attribute, suppose, and then we try to decide that we believe that this attribute, this attribute has a systematic relation with the objective. Then only we do stratification. If we believe that there is a gender difference, all right, gender difference, then you have to stratify this gender, male and female. This is the attribute, and then you have to take care of the stratification in terms of male and female. So therefore, this is called stratification. If we believe that there is a difference between rural and urban, systematic difference, so then we have to stratify the whole sample into rural and urban and ensure that this rural and urban gets represented in the selection when we do the selection method. So therefore, this is called stratification. So this is based on attribute, and it is applied only when there is a systematic relation between the categories and the objective. All right. Now, the next one is the systematic. Now, systematic sample is something that if you have, say, as I have said, suppose that there is a 200 units you want to select a population, and then from that you need to select suppose 20. Then you will first of all you will find 200 divided by 20. So we call it sampling interval. So this is going to be 10. All right. And then what we'll do from 1 to 20, we select anything random. Suppose eight number is selected. So then rest of the things will be every 10th number. That means 8 is automatically selected. 8 plus 10, 18 number will be selected. Then again 10 plus 28 number will be selected. And then 38 number will be selected till we get the 20 units. So therefore, this is what is the idea, and this is how we are going to get the sample. So first part, we have to calculate a sample interval. All right. And then from sample interval, first one to sample interval will be selected at random, and then next will be selected uh, uh, next will be selected accordingly, systematically. System is that each, after first unit, all the units will be of the same number. Now this is what is the system. Now the next important sample, which is called cluster, it is based on area. All right, area. Suppose there is a village. All right, let me have a village. Suppose this is your, this is your village, and you have households all over the place. All right, and you find that, okay, this is the household, and these households are large village. It is a large village, and then suppose the 500 household. So we can split this, the cluster village, into something like this. All right, and then we have three clusters of, say, different sizes. Say suppose the one cluster can have 150 household, 170 household, and then 100, say suppose 80 households. So roughly the almost same number of households, and then any one cluster will be selected. So it's area based. Only thing is that you have to have all the clusters should have should be heterogeneous. You cannot have homogeneous clusters. For instance, suppose if it is all Muslims are here, all Hindu are here, then it will not work. So it has to be a mixed kind of thing. Then only cluster will be happening. So the practically doing cluster is extremely difficult. Normally it is done with a very great care, and then but mostly we do simple random sampling, stratified sampling, and the systematic sampling. Cluster is also done, but it is a little difficult. So these are the different methods of doing it. Now the point that I was trying to make here is that, let me now sum up the whole discussion, and then we will take some questions. The idea is that the method of data collection depends on a couple of things. One, first of all, you need to understand what is your objective. Second, what is your kind of data. Based on these two idea, the objective and type of data, you will decide which method is going to be used. Different methods are there, and all the methods, most importantly, all the methods have their own, the own mechanics of doing it, that when it is to be done, how it is to be done, what are the plus points, what are the minus points. On all these things you have to take into consideration before you take a final call regarding the methods of data collection. The sample survey is used, yes, for understanding and exploration, but mostly for estimation and generalization. And if you want to have estimation and generalization, then you have to take care of all the things, that what is your margin of error, what is your confidence level, and how you have calculated the sample size, how you have selected it. All those sampling framework you have to done, and then only we can go for safe generalization or a good generalization in the statistical sense. So this is the whole gamut of the things that we have when we discuss the the methods and techniques of data collection. And this is an overview. It included everything, and each of these actually requires a detailed discussion, which unfortunately I don't have time to discuss. So we have some 20 minutes time for taking some questions, because it is a very long session. 2 hours is a really, really long session. So therefore, I will be happy if some questions are put, so that we can explain all these things. Thank you.
Thank you so much, sir, for your enlightening speech. Sir, your words on selection and understanding the various sampling methods has benefited us a lot. Now, the house is open for discussion. So I would like to request all the participants to kindly come forward and interact with Sir. Participants can either type your queries in the chat box or you can just unmute yourself and ask. If there is any question from the participants, kindly feel free to ask. Sir, we have one question in the chat box.
Yeah, I got it. The standard error and sampling error. All right. These are two different. One is the sampling error means that since you are taking a sample, you are not going not going to all the population units. So you have selected only a few of the units from the sample. So therefore, it is obvious that your results are not going to be the true results. So therefore, by the fact that you have selected a sample, we acknowledge that there will be an error, and that is called sampling error. So sampling error you cannot eliminate completely. All right, it will be a very coincidental thing if you can have the same result in the population, but we believe that since we have not studied all the units in the population, we have taken only a few. So because we have taken only few, so we acknowledge that there will be difference between the sample result and the population result. So that's what is called sampling error. So sampling error is coming from the fact that we have done a sample. All right, so there will be a difference between the sample result and population result. So that's the idea. So that is the sampling error. Now standard error is something different. Standard error is what? Is that it's a theoretical understanding that since you can have a number of samples, from the same population, all right, it's not your sample is the only sample that is possible. There can be other kind of samples also of the same size. All right, so therefore there is a possibility of having different results from the different samples. Get my point? So suppose you can have 10 samples, so 10 samples will have 10 different results. All right, so if you have 10 different results, then the variability of these 10 different results is called standard error. Standard error is the possible differences in the results of possible samples. All right, so that's the standard error. So it's a theoretical statistical understanding of the possible error which might occur in different samples if we draw those samples from the same population. So that's the standard error. But sampling error is you cannot eliminate. You cannot eliminate because it is a part of sample. It is coming from the fact, it is an acknowledgement of the fact that we have not gone through all the units. So therefore, since we have done only few, so if we try to predict based on few, there is going to be a difference, and that difference is going to be sampling error. So sampling error is inevitable. You cannot eliminate. Standard error is a theoretical error which we can expect in different results in terms of different samples. So that's the difference. Okay, Mridusmita raised the hand. Yes, allow her to speak. Or you can type it in the chat box. I'm looking at that chat box.
Your microphone is mute.
Sorry, sir, my microphone was mute.
Yes. Somebody raised hand. I could see. Yes, Mridusmita Bora. Okay, just.
Do we have any more questions?
You can directly speak or you can type it out in the chat box. I'm looking at the chat box.
Hello, sir.
Yes.
Yeah, this is Padmakshi from Dumduma College. I'm working as an assistant professor in history there.
Okay.
So I just want to know one thing, sir. Sir, can is there a possibility like there is some sort of manipulation or like stimulation of thought process like when we are in the field as a participant observant because since I was into research and I have already done my PhD, so there were some problems which I faced initially, like people are very hesitant in some cases. So can there be some sort of manipulation also, sir, in collecting data when you were in the field and as you were when you were particularly when you were as a participant observant, so participant, you are not taking part directly but you are in the situation, sir. So how do we go about it, sir? Can there be some
Yes.
sort of manipulation too?
Uh, Manipulation means,
Of sir, like while they're giving the well, suppose so we are giving a questionnaire and they have to fill it up, so sometimes it becomes they're hesitant to speak up, so sir, like can the whole system be manipulative, sir? Like
yeah, there is a possibility. I mean, that is why this whole idea of the same taking data in whatever form. When you go for any method, there is always a possibility of doing it nicely, and there is a it is also a possibility of making a lot of mistakes and coming up with long kind of observations.
yes,
There
sir.
is a possibility. Only thing is that when you try to do this thing, then there are different ways of minimizing those probabilities. All right. Suppose participant observation method has all different kinds of problems which are very different from other kinds of schedule and survey. In survey, for instance, suppose in survey, what is there? The basic idea is that you take the response for granted. Whatever people say, you have to note it down. So,
Yes,
it might happen that they can actually may not give the correct answer. For instance, all right, they can hide information. They can state wrong information. They can
we have
do
this
all sorts of stuff. All
yes,
right,
sir.
I
Yes,
can
sir.
give you one example. That this is a good example. Uh, the UNICEF, for instance, in a
Yes,
global UNICEF I'm talking about, they have
yes, sir.
conducted a survey all across the world, and then one part was also done in Assam. Then that is regarding the immunization, all right, the
Yes,
child
sir.
immunization. So and then we were to ask the age of the children, all right, because immunization normally done during the first 9 months, all right. So
Yes,
therefore, we were to ask about their ages, and the people we asked that what is the age of your child, then they normally do not recall. Most of the people do not recall the exact age or exact date of birth. So they when they wait to answer, then our investigator prompted that is it 1 year or is it 2 years or is it actually 1.5 years. So in that sense, then they say that okay, it is one year. So you actually prompt the investigator prompted the respondent, and respondent said yes. So
yes,
that actually can happen. So this is a one kind of manipulation. So these are called interviewer bias, non-sampling, bias. All sorts of bias can come in. Now, I will not have time to discuss how these bias can be handled in different methods.
I understand. Yeah.
Get my point?
Yes.
It's very difficult to take all the question, all the methods and looking at their pros and cons. It is not possible. But you have rightly pointed out that there is a possibility of getting corrupt results because of different sorts of bias coming into the process of collection in whatever method you choose. Get my point? So
Yes.
even in FGDs, it so happens that one person dominates the discourse, and then that is why I've said that you just cannot go to a village and constitute a group and then start talking. So you
Exactly.
have to actually do a lot of pre-work, understanding their dynamics, group dynamics. If you get 5 people together and one happens to be suppose a panchayat member, then people will simply follow. So therefore, if you want to constitute a group, then you have to be there for several times, and then identifying people, and then constituting a group, and then leading the group. So then only FGD will work. Now normally what happens if people go and collect 6 7 people and start talking and you call it an FGD? That's not an FGD. All
Yes,
right.
sir.
So therefore, even ethnography problem is different. Then how do become objective without being prejudiced by your own subjective ideas while remaining in the setting? So those are the different issues which are important, and you are correctly pointed out. You have correctly pointed out that there is a possibility, but at the same time, you should be also aware that there are also methods of eliminating those possibilities.
Yes.
Okay, so that can be discussed only when we have a specific session on, say, suppose ethnography, doing
Yes.
ethnography. Then we can discuss all these things. But it is a very overview kind of, large canvas kind of session where we are not going into those details. I'm just, laying out different methods which you can actually apply.
Yes.
All right, and then
Oh,
I'm basically concentrating on the fact that you should know when to apply what.
yes, sir.
Okay, that is the point of this presentation. That if you are interested in estimation, then you should take this route. If you are not interested, then you should take this route. So that's the point that I was trying to highlight.
Thank you so much, sir. Thank you.
Thank you, sir. Sir, we have some questions in the chat
Yeah,
box.
yeah, yeah. I have seen this, Juthika. Okay, to be objective in research like gender studies, conflict studies, and community studies is very challenging. Sometimes the barrier between subjectivity, this I have already pointed out. So how to remain objective is a kind of subjective. Okay, so this is a very difficult subject to answer simply. Uh, the idea is that the question is that can you be completely objective? Can you be completely objective? Uh, my understanding is that it's very difficult, and it's not required sometimes that you need to be very objective. Social science research is unlike the natural science research, always guided by the kind of ideology, kind of the kind of approach that you want to take. So therefore you can remain objective to in a relative sense, but uh, getting rid of subjective element and your ideology is extremely difficult. And there is also a debate in social science that whether it is at all desirable to be so objective, so as to be devoid of your own subjectivity. So I'm not going to discuss too much on this. I guess it will not have time for this, but I encourage you to read the recent debates regarding this kind of issues, which are plenty, and then you can get some sense of it. Uh, in case the population size is not known, how to select the sample size? You have a correction formula, correction factor in the formula. If you have known sample size, you can use that directly. But if you do not know the sample size, then there is a correction formula which can be applied. And in different softwares, it is already fixed. For instance, suppose I showed the Rasoft online software, where if you do not know, you can put anything more than 20,000. It takes as that population is unknown. So therefore there are different ways of putting the value which will recognize that the population is unknown. So that's how it is done. Now another question by Probin Iraqi. If
Parveen
we want
Iraqi,
to,
ma'am.
yeah, Parbin, yes. If we want to conduct epidemiological study in a large area or a district, then what sampling method we should use? Okay, that depends on the objective, what you want to do. If you want to stratify, you can do stratify. As I have said, that you must know that when stratification is required. Suppose epidemiological study, I don't know what kind of epidemiology you are talking about, but in general, for instance, suppose take for example, you want to do a study on any of the epidemiological disease in a large area or a district, then the idea, you can have a stratification provided you have an hypothesis that the prevalence of epidemiology under question is actually the have a systematic relation with different attributes like rural urban, like income group, like gender, male female, like age group, like other characteristics. If you have that kind of an hypothesis in place that these characteristics have a bearing on the prevalence of epidemiology, then you have to stratify. Okay, the stratification is done on the characteristics where we believe or where we have an at least hypothesis that this characteristics is systematically related to the objective that under question. So if your epidemiology is studied with that perspective, that I want to see the difference of prevalence of this disease across different age group and gender, then you have to do a stratification based on gender and age group. And then you have to calculate those figures, estimate those figures for different groups, and then you have to study whether there is a statistical significant difference in the prevalence rate of within these groups that we have already constituted. So if you have that, then you can say that okay, there is a significant difference in the prevalence within this among these groups. Or if you conduct a test and then you have found that there is no significant difference, then hypothesis will be rejected. So that's how it is to be done, and that is where the certification is to be done.
Thank you so much, sir, for your beautiful explanation. I hope, Parveen ma'am, your query is answered.
Thank you, sir. Thank you so much, sir.
Okay.
So participants, please feel free to ask any query if you have.
Yeah, we have some 5 minutes time, so we can get 2 questions at least, 1 or 2. Or maybe there's, yeah, I don't see anything, so maybe that's it.
So do we have any more questions from the participants? Okay, if not, then I think we can conclude the session 1. So on behalf of everyone, I once again thank you, sir, for giving your valuable time. We are hopeful for having many such interactive sessions in future with you, sir. Thank you so much, sir.
Thank you. Thank you. Thank you. Great to be here.
So we have an